Hello students, welcome to Mathematics video lesson with yours truly, Mom Lorena S. Maglonso. So the materials needed for our lesson today are ballpen, paper, and of course your module 2 for quarter 3, which is the axiomatic structure of mathematical systems. Here are the objectives for this lesson. So at the end of this lesson, you're expected to 1. Define axiomatic structure of mathematical systems. 2. Illustrate the need for an axiomatic structure of mathematical system in general and in geometry, particularly undefined terms, defined terms, postulates, and theorems. And last, create models for axiomatic structure of mathematical systems. But before we proceed to Module 2, let's have a short review or recall of what is in Module 1. So in Module 1, we have discussed the mathematical system. And mathematical system always starts with undefined terms, followed by definition, axiom and postulate, theorem, and corollary. We also discussed the four important components of mathematical system, which are the undefined terms, definition, axioms and postulates, and theorems. We also discussed the father of geometry, Euclid, and his book, which is entitled The Elements. Now, let's recall the Euclid's different definition, axiom, and postulate. So, you're going to tell if the statement is definition, or you're going to tell D if the statement is definition, A for axiom, and P for postulate. Are you ready? Okay, now, let's start for number 1. The ends of a line segment are points. Is this definition, axiom, or postulate? If your answer is D, you are correct because that is Euclid's definition. Next, number 2. The whole is greater than the part. Is this Euclid's definition, axiom, or postulate? If your answer is A, you are correct. This is Euclid's axiom. Next, number 3. A terminated line can be produced indefinitely. Is this axiom, definition, or postulate? Okay, the answer is P. This is Euclid's postulate. Number 4. All right angles are equal. Definition, axiom, or postulate? The correct answer is P. This is Euclid's postulate. Next, for number 5. Things that are doubled of the same things are equal to one another. Axiom, definition, or postulate? The correct answer is A, axiom. Very good. Next, for number 6. A straight line extends indefinitely in both the direction. Definition, axiom, or postulate? The correct answer is letter D. This is from Euclid's definition. Number 7. A surface is that which has length and breadth only. Is it an axiom, a definition, or postulate? Okay, very good. The answer is D, definition. Next, number 8. Things which are halves of the same things are equal. Is it Euclid's definition, axiom, or postulate? The correct answer is letter A. Very good. This is from Euclid's axioms. Number 9. A circle can be drawn with any center and any radius. Is it Euclid's definition, axiom, or postulate? Very good. The correct answer is postulate. P. And last, number 10, a line is a breadthless length. Is it from Euclid's definition, axiom, or postulate? Very good. That is the definition. If you got 10, very good because you really understand the lesson in Module 1. Now, let's proceed to Module 2, which is the axiomatic structure of mathematical system. So, what is axiomatic structure of mathematical system? When we say axiomatic structure, this is a list of undefined terms together with a list of actions which are presupposed to be true, its definition in proving theorems, and other components of a mathematical system. So these are from undefined, then together with a list of axioms. We also have theorems, which is any statement that can be proven using logical deduction from the axioms, and a model which is used to illustrate or to define the undefined terms so that the axioms are true. So these are what we're going to use in proving the axioms. Now, there are characteristics of an axiomatic system. There are three, and these are independent, consistent, and complete. When we say independent, an axiomatic system is independent if it cannot be proven from the other actions. So meaning, to prove that one axiom is independent from all of the others, you need to find a model in which the axiom is false, but all of the other axioms are true. So, ibig sabihin, para masabi mo na independent yung axiomatic system mo, kailangan meron kang model kung saan pwedeng yung isa axiom ay false, pero dun sa other axioms ay true. Next is consistent. An axiomatic system is consistent if there is a model for an axiomatic system where the axioms are all true. So here, to prove that an axiom is inconsistent or consistent, there should be no internal contradictions among them. Otherwise, it is inconsistent. So, kapag na-prove natin na walang model na nag-exist, that is inconsistent. So, para maging consistent siya, kailangan lahat ng axioms niya ay true and wala tayong magiging contradictions. Next, the last one is complete. An axiomatic system is complete if every true statement can be proven from the axiom. So, dito kailangan lahat ng true statement natin ay ma-prove mula dun sa axioms. And in mathematics, there are many conjectures that have not been proven. Now, let's have an example. For illustrative example 1, here is the axiom system. We have here 4 axiom. Axiom 1, each committee is a set of 3 members. Axiom 2, each member is on exactly 2 committees. Axiom 3, no 2 members may be together on more than 1 committee. And axiom 4, there is at least 1 committee. We have here question letter A. What are the undefined terms in the axiom system? The answer is the undefined terms are committees and members. So these are the undefined terms in this axiom system because committees and members are the terms used in the formulation of the axiom. So, ito yung ginamit kasi dito na sa ating mga axiom. And yung tinatanong na undefined terms is dun nanggaling sa axiom system. Next is letter B question. What is the model for this axiomatic system? So, the answer is a model for an axiomatic system is a way to define the undefined terms so that the axioms are true. So, ito yung kanina nating sinabi. So, ito yung gagamitin natin para ma-define natin yung mga undefined terms dun sa axioms na true. So, we have there the undefined terms, members, and committees. So, for example, ang members natin are Alan, Beth, Chris, Dave, Elena, and Fred. And then, we form a committees. So, from action 1, ang sabi daw ay each committee is a set of 3 members. So, nag-form tayo ng 3 members in each committee. Next is, so we're going now to check if yung ating 4 actions satisfy dun sa, uh, ayun, if the actions are satisfied. So, for action 1, each committee is a set of 3 members. So, yes, nag-satisfy siya. So, yung ginawa nating model kanina ay consisted of 3 members. For action 2, each member is on exactly 2 committees. So, we have here a list of committees in the model containing a member that is found on exactly 2 committees. So, si Alan, so we have here 2 committees. So, andun si Alan, both in the committees. So, same with Beth, Chris, Dave, Elena, and Fred. For action 3, no two members may be together on more than one committee. So, here for this action, there are total combination of 15 pairs of members. So, what you're going to do is you should make sure that none of the pairs is on more than one committee. So, kaya ito, isa-isang committee lang siya. So, nandun si Alan and Beth, isang committee lang. Si Alan and Chris, dun lang sa isang committee na yon. So, hence, it is acceptable to have the pair of members be on no committees or one committee. So, accepted daw na pwedeng si, example, Alan and Fred, wala siyang committee or nandun lang siya sa isang committee, but not two or more based on action 3 and 4. So, if you can see, sabi naman, nag-satisfy yung action 3 and the number is less than or equal to 1. Next, for action 4, there is at least one committee. So, ayun, meron tayong at least one committee here. And for question letter C, is action 1 independent? So, here action 1 is false because the committees are not composed of exactly 3 members. However, action 2 and 3 are 4 are true in this model. Then, action 1 in this model is independent. So, sabi ko nga kanina, independent siya kapag meron tayong isang false action pero dun sa other actions ay true yung ating model. And for example, or for question letter D, is the axiomatic system consistent? So, since we have come up with a model for this axiomatic system, then the axiomatic system is said to be consistent. Now, let's have illustrative example 2. So, we have here 3 axiom. Axiom 1, every ant has at least 2 paths. Axiom 2, every path has at least 2 ants. And axiom 3, there exists at least 1 ant. For question letter A, what are the undefined terms in the axiom system? Can you tell? Okay, very good. That is, those are ants and paths because those are the terms that are used to form the axiomatic system. Then for letter B, illustrate the model of the axiomatic system. So, it is said in axiom 1 that every ant has at least 2 paths. So, meron tayo ditong isang ants, dalawa yung paths niya, paths A and B. So, bawat ant daw may dalawang path. For axiom 2 naman, sabi, every path has at least 2 ants. So, dapat daw yung dalawang path may dalawang ants. So, itong path natin, path A and B, ayun, meron tayong dalawang ants doon and also the other. And then, for action 3, there exists at least one ant. So, ayan, meron tayong nag-exist na at least one ant. Next is action 1 independent? So, using the model, we can conclude that the action 1 is independent. So, this is a typographical error, independent, because the two ants share only one path, that is AB. So, is AB lang siya. So, in action 1, there should be at least 2 paths. So, sabi kasi sa action 1, kailangan dalawa yung paths. Eh, dito sa model na to, we only have 1 path. Should at least 2 paths. 1 path lang yung nung dalawang ants. So, for every ant, dapat dalawa yung paths niya. However, using the same model, satisfy action 2 and 3. Pero nagsasatisfy naman siya sa axiom 2 and 3. So, this is independent. And for question letter D, is the axiomatic system consistent? Since, again, we have come up with a model for this axiomatic system, the axiomatic system is said to be consistent. And that's all. Now, let's sum up. So, what is the axiomatic structure of mathematical system in geometry? Okay, this is a list of undefined terms together with a list of axioms. Very good. How about, how do you know if an axiom of an axiomatic system is independent? Okay, again, an axiomatic system is independent if it cannot be proven from the other axioms. So, to prove that one axiom is independent from all of the others, you should find a model in which the axiom is false, but all of the other axioms are true. And how do you characterize a consistent axiomatic system? So, a consistent axiomatic system can be said to be consistent if the model for an axiomatic system are all true, and the axioms of an axiomatic system are consistent if there are no internal contradictions among them. And for question number 4, how do you characterize a complete axiomatic system? Okay, if every true statement can be proven from the axioms, then the axiomatic system is complete. And that's it for today. I hope you understand uh, the lessons for this day. Thank you.